Hello everyone, welcome to Helm of Science. So the West Bengal joint examinations are over and the results have also come out. The joint entrance main examination for the month of July is over and the results have also come out for the same. So we are only left with one more joint entrance examination, that is in the month of August or preferably in the month of September. So for that, now since that is the last opportunity for us to qualify that exam, so our preparation strategy would be little different. What should be the strategy? The strategy should be less of learning and more of practice. Practice of questions, right? From the last 10 years or last 15 years, whichever is comfortable for all of you. So that should be our motive, right? So no more of going through the textbooks or going through line by line of any particular chapter. Instead of doing that, what would be beneficial is you go through questions of every chapter that have come previously and analyze the paper, analyze how that the questions are coming from which part more often, which are the topics that are being repeated constantly in the questions. So you need to focus on those topics, right? So in today's series, I have already started off with a series of different chapters and their related questions from the joint entrance examination. So today we'll do one more such chapter, which is chemical bonding. Now, to be very frank, this is one chapter which is the easiest in the entire chemistry syllabus because the questions are very direct, very on point, and uh, and it's got a very simple approach to it. There is nothing very complicated in the chapter. One more important thing which needs to be mentioned in this chapter is the thing that very few topics are touched, like molecular orbital theory or hybridization shape. You'll see in the questions when I do it, you will understand that the questions are being repeated only from these sections and nowhere else. Hydrogen bonding, maybe some amount, molecular orbital theory, shape, hybridization, structure. These are the topics which are frequently asked. So your focus should be on these topics and these concepts, right? So without wasting any more time, let us just get into the questions. So the first question is very simple and very direct, which has been asked in 2019 of your mains examination. Very basic concept. That is the isoelectronic set of ions. Now the term isoelectronic needs to be understood first. Isoelectronic is same number of electrons. Okay, same number of electrons means isoelectronic. So what do we have? F minus, Na plus, Mg2 plus, and we have another one is Li plus. So fluorine has an atomic number of 9. It has gained 1 electron, so the total electrons is 10 here. Sodium is supposed to have electrons equal to 11, but it has lost electrons, so it has become 10. Magnesium 12 electrons, but 2 plus meaning 10 electrons. Lithium had 3 electrons plus 1 meaning 2 electrons. So they are not isoelectronic. These three have same electrons, but this is not. Right? So this option gets cancelled. Let us move on to the option which says N3 minus, O2 minus, F minus and Na plus. Now why did I say so? See, you should be very smart when you're attempting a question. Options B and C have lithium. Now when lithium is an option with these two, right? Sodium, magnesium, or for that matter fluorine, it can never compare or get compared to the number of electrons that these species have, because obviously the number of electrons in lithium is less. So in whichever compound or whichever combination you give lithium along with any of these, it will not satisfy for sure. So on that basis, you have lithium with magnesium in option number 2, not possible. Lithium with sodium in option number C, not possible. So those two options get eliminated directly, right? Coming to the fourth option, N3 minus, O2 minus, F minus and Na plus. This we have seen electron is 10. This also we have seen electron is 10. Coming to this one, O has an atomic number of 8. 2 electrons means 10. Nitrogen has an atomic number of 7. 3 electrons means 10. So all the electrons are same. So our answer should be option number D. So you have to be smart when you are doing the questions. You cannot go on analyzing every option. You have to eliminate options. That's the only trick. Alright, to save time. The next question says there are 4 compounds: toluene, metachloro-dichlorobenzene, ortho-dichlorobenzene, and para-dichlorobenzene, and you have to arrange in increasing order of their dipole moment. So what are the compounds given? It is given as toluene, number 1. Then you have meta-dichlorobenzene. Then you have ortho-dichlorobenzene. I'm assuming that you know which one is ortho, which one is meta, and which one is para. Alright, I think that much you have prepared yourself before seeing the solution video. Alright, so what do we have? We have 4 compounds, and we are supposed to be arranging it in order of their increasing dipole moment. Right? So what is dipole moment? Dipole moment is basically, it occurs when there would be an electronegative species, any electronegative species, and there will be a separation of charge between the species. Like here, there is carbon and chlorine, so there should be a slight separation of charge, right? Whenever there will be a separation of charge, that should be in the direction of the more electronegative element, which is depicted as the dipole moment. Dipole moment is the force into or the torque in a particular direction, right? That is dipole moment. So now how do we analyze? In these 3, chlorine is the more electronegative one, so we know that the dipole moment will be directed towards it. Now see what happens. In the para one, see, if this side the dipole moment has a unit of 10, suppose, and then this side also has a unit of 10, since both are chlorine atoms, then it will get cancelled out because they're in opposite directions. So this should have the least dipole moment, right? So 4 should be your last option. So by just seeing that option, I think you can eliminate option number 1 from it, right? Now coming to orthochlorobenzene and meta-dichlorobenzene. See, in ortho, the dipole moment are almost in the same direction. In the meta one, if not absolutely opposite like the para one, it is to some extent opposite. It will have a value of dipole moment, but lesser than this ortho product, right? So the ortho one should have the highest dipole moment, 3, and then it should be 2. So that option, I think, clears that option number 4 will get eliminated. Correct. Now you have option number 1 and option number B and C in your hand, because option number 1, A, gets cancelled because the last option is not 4. So the thing is, where should toluene be? Toluene should be just next to or just before the para-benzene. Why? Because in the para one, the dipole moments are getting completely cancelled, right? So, but in toluene, there is no cancellation. Neither is there any electronegative element to contribute to toluene to the dipole moment that much. So it will have some value, maybe intermediate value. That is why we are keeping it not absolutely in the front compared to the meta and the ortho one, and not at the end, because it will have some value which would be greater than the para one, because that should be a 0 element since they are absolutely opposite, right? So this brings us to option number 4, 1, 2 and 3. So that is option number B. Clear? Moving on to the next question. The next question states that the correct statement about ICl5 and ICl4 minus is. So let us just write down the compounds ICl5 and ICl4 minus. Using VSEPR theory, what will we do? So VSEPR theory, the central atom contains 7 valence electrons plus 5 substituents, make it 12 electrons. And this is 7 valence electrons plus 4 substituents plus 1 extra electron. So this is also 12. Okay. Now let us kind of draw the structures. Both should be octahedral. Right. Both should be octahedral. So first let us try to draw. For ICl5, what should be it? Now in octahedral species, the lone pair is occupied in the axial position. We know that because of greater S character. And for this one, this should be something like this. Now the shape here is like a square pyramidal. Square pyramidal means all the atoms on the same plane. Sorry, square planar, all the atoms on the same plane. And this is like a square pyramidal, which is on the same plane there are 4 atoms and one like a pyramid. So that is the square pyramidal structure. So ICl5 would be square pyramidal and ICl4 minus would be square planar. That is your option B. So VSEPR is the best way to solve such questions. Alright. Now the next question says, in which of the following processes the bond order has increased and paramagnetic character has changed to diamagnetic. So both the things you have to justify. Paramagnetic changing into diamagnetic and bond order changing, right, or increasing. So there is a trick I can tell you, that is, if the number of electrons is less than or equal to 14, then in your 2p shell, 2p orbital, the pi orbitals are below and the sigma orbitals are above. Alright. And if it is greater than 14, then the sigma orbitals are below and the pi orbitals are above. So what do I mean by it? Suppose I do it for O2. So O2 meaning 16 electrons. So greater than 14. So how do we draw? Now I'm not going to draw in a very proper format, alright, because it will take time. I think all of you know molecular orbital theory, so I'll not waste time. So O2 means 16 electrons to here, sigma 1s, sigma star 1s, right? 2s will also have sigma 2s and sigma star 2s, right? Correct? And there will be a 2p orbital, which will, so I said 16 electrons, so the sigma should be below and the pi should be above. Pi 2px and pi 2py. And there should be a corresponding pi star and a sigma star. Right? 2pz. So this comes from the 2p orbital. Correct? Now 2, 4, 6, 8, 10, 11, 12, 13, 14, 15 and 16. Right? So our bond order becomes number of electrons in bonding 2, 4, 6, 8, 10 and minus number of electrons in antibonding. So that is 2, 4, 5 and 6 by 2. That is 2 bond order for oxygen. So oxygen has double bond. That is for sure. Now it is said that it is changed to O2 plus, means 1 electron is lost. Right? So what would be the bonding electrons? 2, 4, 6, 8 and 10. And anti-bonding electron would be 2, 4 and 1, 5. So this is for O2. So for O2 plus, it should be 10 minus 5 by 2, which is 2.5. So bond order has definitely increased, but has it changed from paramagnetic to diamagnetic? No. Diamagnetic means there should be paired electrons, but in this case it is not. So that option is ruled out. Right? Now moving on to NO, which says, before NO there is another oxygen, I think. Okay, O2 2 minus. So O2 was electron here. So O2 2 minus would be 2 more electrons. So first thing that you can see is that it has changed to diamagnetic. That's for sure. Now, has the bond order increased? That is the question. So 10 was the bonding electrons and antibonding becomes 2, 4, 6 and 8. No, the bond order is not increased. Now coming to NO, that means NO is 7 plus 8, 15 electrons, again greater than 14. So this diagram is valid. 15 electrons meaning, I'll use a separate pen. 15 electrons means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay, bond order becomes 10 in the bonding and anti-bonding is 2, 4 and 5. Yes, 2, 4 and 5. So that becomes 2.5. Now NO plus means this electron is lost. So this is diamagnetic, all the electrons are paired. But let's see if the bond order has increased. So this should be, bond order is 10 minus 2 and 4, right? So this should be 6 by 2. Yes, the bond order is increased. So this should be your answer. So we have got the answer to be D, but I just want to show you the diagram for molecules having lesser than 14 electrons or equal to 14 electrons. So in case of nitrogen, it is equal to 14 electrons. So the sigma 1s, sigma star 1s, sigma 2s, sigma star 2s remains the same. For pi, the antibonding orbitals also remain the same. Right? Where is the change then? The change is here in the above one, we had written sigma below and pi upwards. For less than 14 electrons or equal to 14 electrons, you will write the pi orbitals below and then the sigma orbitals. Okay, that should be your correct way of approach. Alright, and then you can fill the electrons and check it for yourself. Moving on to the next question, the total number of lone pair of electrons in I3 minus is. So I3 minus is, first of all, you have to draw the structure. So to draw the structure, let us just start off I3 minus, right? That's the question. So we can write it as I2 minus. This being the central metal, 7 electrons, 2 substituent and 1 charge. So this should be 10. 10 electrons meaning trigonal bipyramidal structure, isn't it? So trigonal bipyramidal structure will lead to what kind of shape? I. Now in TBP structure, the lone pair should be in the equatorial position. Why? Because of the simple fact that equatorial position is greater S character, greater S character. So the equatorial position will be occupying the lone pairs. So it's a linear structure, number 1. Now how many lone pair of electrons are there? Total number of lone pair of electrons. So 2, 4, 6, right? And if you say that's it, no, it is not so. See, so 1, 2, 3, 4, 5, 6, 7, 8 and 9. These elements also have lone pairs. So there will be 9 lone pairs altogether. Alright, clear? So that should be option number C. Moving on to the next question, the species having pyramidal shape. So pyramidal shape would be, what are the options given? SO3, BRF3, SiO3 2 minus and OSF2. So we'll use VSCPR to solve the question and it will become very easy. So SO3 means central metal sulfur, which is 6 electrons, and for oxygen you have 1 sigma and 1 pi. So effectively it's 0. So you get 6 electrons. This is trigonal planar. How do we draw it? This is trigonal planar structure, right? Now moving on to the next one, BRF3. BRF3 is 7 plus 3, 10 electrons. TBP structure. Now let's see how it can be drawn. So BRF3 and there are 2 electrons, right? So it is like a T shape. This is not pyramidal, it's a T shape. See, this is the T shape, right? Next one is SiO3 2 minus. So SiO3 2 minus meaning Silicon is 4 plus 2 electrons plus 3 into 1 minus 1, so 6. This is again planar, right? This should again be planar. Double bonded O and 2 minus. Right? Now, what are we left with? OSF2. So, the central metal is 6 plus 2 fluorine, 8 electrons, and oxygen should be 1 minus 1. So, 8 electrons meaning it should be a tetrahedral structure. Let's see how it should be. So, this definitely looks like a pyramid, isn't it? So, this would be your pyramidal structure. So, your option would be option number D. Okay. Moving on to the next one. The bond order and magnetic nature of the diatomic molecule B2 is. Okay. So, what can we do for that question? Now, for that particular question, how can we begin? See, B2 means how many electrons? 5. Atomic number is 5, so 10 electrons total. Less than 14. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Less, so it should be pi 2px, pi 2py, sigma 2pz, pi star 2px, pi star 2py, sigma star 2pz. Right? Now, if Hund's rule was followed, then how would we have filled it? 2, 4, 6, 8, 9 and 10 first singly and then pairing it. But then in the question it says that the Hund's rule is being violated. Right? So if the Hund's rule is being violated, then what happens? The electronic arrangement would be in 2py, it's 2px or 2py, any of the two. It should contain both the electrons instead of having electron in the other one. Right? So what should be our bond order in that case? Bond order would be 2, 4, 6 minus 4 by 2, that is 1. The bond order should be 1 and it should have been paramagnetic, but we have violated the Hund's rule. So now it has become diamagnetic, right? So you have to read the question properly. Otherwise, you would have marked 1 and paramagnetic as your option. So that would not be the option. The correct option would be option number A. Right? Moving on to the next question, the hybridization of the central atom. Now this is again VSEPR basic concept. Ammonia, this is tetrahedral. So this should be sp3 hybridized. Then you have PTCl4 square planar structure. Since it's way down the group, so it will occupy a square planar structure. Square planar meaning EsP2. Okay. Then you have PCl5, 10 electrons, TPP structure, sp3d. And then you have BCl3, boron, 6 electrons, planar structure. It should be sp2. So sp3, dsp2, sp3d and sp2. That should be option number B as a correct answer. Moving on to the next question, the common features in Cn minus, carbon monoxide and NO plus are. So Cn minus, first count the electrons, 6 plus 7, 13 plus 1, 14 electrons. CO, carbon monoxide, 14 electrons, and NO plus means 14 electrons. So they are isoelectronic, right? So one option you have, that is option A, that you can already tick, but you can just check that whether the bond order is 3 or not for all of them. So how do we do? Both have, all the 3 have 14 electrons, so it should be the structure of nitrogen itself. So sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, 2py, sigma 2pz, then you have pi star, and then you have sigma star. Okay, 2, 4, 6, 8, 10, 12, 14. So your bond order would be 2, 4, 6, 8, 10 minus 4 by 2. That is 6 by 2, which is 3. Bond order is 3 for all of them. Right? So that is how you will uh, uh, eliminate your options. Right? Okay, now weak field ligands, none of them are weak field ligands because we have learned that organic ligands are strong field in our spectrochemical series and coordination chemistry. So the option D, even though it is isoelectronic, it will never be weak field ligands. Option C, as it is eliminated because they are neither isoelectronic, option is not mentioned, and bond order is also wrong. So again, option B is wrong because again weak field ligand is mentioned even though the bond order is correct. So this is how you have to analyze and justify your answer and proceed with the question. Alright, moving on to the next question is the question says, during the change of O2 to O2 minus, the incoming electron goes to which orbital? So O2 means 16 electrons, so our diagram changes a little bit. So sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz comes below, then pi 2px, pi 2py, then pi star, and then your sigma star, right? Sigma star 2pz. So O2 minus meaning 17 electrons, 8, 10, 11, 12, 13. Wait, 1 minute. Yes. 2, 4, 6, 8, 10, 12, 14, 15, 16, and 17. So the incoming electron goes into pi star to px. So your option would be B. Right? Next question. According to MOT, which will not be a viable molecule? So the options which are given all are 1s and 2s containing orbitals. So we'll not draw the whole structure. So let's just draw sigma 1s, sigma star 1s, sigma 2s, and sigma star 2s. Right? Now, what do you have? You have helium. First option is helium 2. Helium 2 is 4 electrons. 2 plus meaning 2 electrons. 2 electrons in 1s. So our bond order would be 2 minus 0 by 2, which is 1. Possible. Possible. So that is why this is a viable molecule. Now coming to He2 plus. He2 plus means 3 electrons. 3 electrons meaning 2 minus 1 by 2. That is 0.5. Bond order 0.5. So this is a problem. H2 minus would be again 3 electrons. Right? So that will also not be a... so bond order would be 0.5 again. Now you have H2 2 minus, which is 4 electrons. Now what is the problem? See, 4 electrons means 2 minus 2 by 2, which is 0. So bond order 0.5 is still fine, but bond order 0 means there is no bond formed. So that will not be a viable molecule. So your answer would be option number D, which is H2 2 minus. Moving on to the last question of this series, that is chemical bonding, is SF4, CF4 and XCF4 molecular shape of them are. Okay. So how do we do? SF4 means 10 electrons TBP. Draw the structure. Right? CF4, 8 electrons, tetrahedral. And then XCF4, 12 electrons, octahedral. Right? This should be my structure. So now let's go through the question. The molecular shape is different, obviously. There is nothing similar here. And how many electrons? This is 1 lone pair, 0 lone pair, and 2 lone pair. So the molecular structures are different with 0, 1, and 2 lone pair of electrons respectively. So your options should be option number C. So if you go through the questions carefully, you will see that most of the questions are asked from MOT. Then you have questions from shape, hybridization. These are the common, how is the bond order changing, how is diamagnetic and paramagnetic property changing, Related to the bond order, there can be bond length questions also, because the greater the bond order, shorter will be the bond length. So that thing also you should keep in mind. So these are the questions which are preferably asked from the chapter chemical bonding. So these are the topics that you should focus more and more, right? And I guess all the solutions are clear to all of you. If you have any other approach to the questions, you can let me know in the comment section. And if you have doubts in any of the question, that is also most welcome in the comment section. So keep preparing, and we shall meet in the next series. Thank you.